Another option for the auto tune sequence is what we call a non-rotational auto tune. I'm going to go and open the drive up. I'm going to go to the auto tune directory, open it up, motor parameter tuning group. Now I'm going to go to what's called stationary auto tuning 1. Now this is selected when one cannot decouple the motor from the drivetrain on the particular crane motion. When this is selected, the initial portion of the auto tune will not rotate the motor. And I'll explain this further as we get into this. So in applications where you do not want to or cannot rotate the motor, this is what one wants to select. We're going to open this up. And again, this is going to be the motor nameplate data on the motor that I'm connected up to. Now, there's going to be a lot of things that will match. This is using information I had previously installed in the drive. And this should pretty much be the same. So this is the motor nameplate horsepower. This is its voltage rating. This is the motor rated current. And again, this is a dual voltage motor. So this is the motor rated current at 230 volts. The base frequency on the motor nameplate. Number of poles, 1750 RPM. We want to change this to the motor rated RPM on the nameplate, which is 1755. It does ask the encoder pulses per revolution. Again, we're using a 1024. And now it says enter motor no load current. Okay, if you don't know this, what it is, leave the default setting in the drive. At this point, I don't see it on the motor nameplate, so we're going to skip this. And now it says enter motor rated slip. If you don't know this, leave it alone. Just skip over it. Now, in the Series 5 drive, which is what we're using for this demonstration, there's an additional question that comes up that you do not see in the Series 4 or the Series 3 or previous drive models. This question is asking, test the motor rotation. Okay, it is advisable, and what matches previous drives, to set this new parameter question in the Series 5 drive to yes. Okay? And then it says enter no load voltage. Again, we're going to leave this alone because we don't know what that is. Okay. Now, this is important to note here that the motor does not rotate. Voltage is applied to the motor. So in other words, the motor is going to be energized and provide your typical arc flash protection and so on that may be needed depending upon where everything is located and where the individual doing the auto tune might be. And again, we're going to press the green key. The brake will not release, but the motor won't turn, so it's a non-issue. Okay, so now we're going to press the green run key. And it says end tune successful. Now, what we want to do is press this key, and it set up these parameters. Now, what has to happen if we do and selected yes, in the previous question I described here, we're going to go to the home. We're going to give this drive a run command with respect to the input to terminal S1, which in the case of a hoist motion would be in the up direction. In the manual on page 68, it makes a point to tell you that step number 5 in the manual, when the auto tune is complete, it will say end tune successful. Okay. If we want to get an accurate way to determine the slip in the motor, which is going to be important for things like microspeed operation, you're going to need to run the motor in the up or S1 direction, which I will demonstrate now. And the drive is basically finishing its auto tune. And now you get an ATC, auto tune complete, on the display of the drive. And now that completes non-rotational auto tune. Let's go back real quick and look to reinforce what I was talking about. We're going to go back down to auto tune and open it up. We're going to look at the stationary auto tune. We're going to cruise through these parameter questions here. Okay, this is what I was addressing previously. In order to get an accurate measurement of the motor slip, we strongly recommended that you set this question here, test the motor rotation, set this to a yes. If you leave it at no, you don't have to run the motor at all. But we can't guarantee that it's going to be the most accurate speed regulation during low speed operation, like microspeed, the microspeed function in our drives, without doing this, the rotation at the termination of the first portion of the non-rotational auto tool.